So the topic of today is different regression techniques. So what is basically regression? Regression is a technique in machine learning in which we predict a continuous value. That value is like continuous and it consists of various data set points, and through that data point the line of regression is drawn, and then we have different other techniques through which we can also uh, perform regression. So we'll dive into these regression techniques. So first of all comes decision tree regressor. Uh, like a decision tree can be used in classification, and it can also be used in regression. So what is decision tree? Decision tree basically splits the data into different subsets. Each of the subset uh, verifies a specific attribute of the data, and then the data is passed on to the next subset, and then as shown in the figure, it consists of nodes, and each node assesses a different attribute of our data, and it can be used to perform regression when particularly dealing with a data set in which we want predictions, in which we want to see a continual value prediction. So we will use decision tree regressor, and what happens is that it on every single node there is a decision that is made, and through which we can make a variety of decisions, and we can predict different types of data sets. uh, Decision tree regressors can be used on different real case scenarios. Like you can see in sports that a prediction is given that which team is going to win, the win percentage of the team is given, a prediction is given that this player is going to score these much goals in this tournament, and there are different predictions, and all of those are made using machine learning algorithms, and all of the data is fed to this decision tree regressor, and then it predicts different outcomes. So next is our random forest regressor. Random forest can be used in classification as well as regressor. So random forest regressor is like it consists of different trees, and trees like in general trees make up a forest. Likewise, it consists of different trees. Each tree is required to perform independently and then to provide out a result, and that result is then further manipulated, and then based on average prediction and majority voting, the final answer is given. The next regressor we have is gradient boosting regressor. Gradient boosting regressor basically also consists of different multiple decision trees, but this time these decision trees are uh, combined sequentially. Like after the data set has passed through one decision tree, it is passed through the second decision tree, and then to the third. What happens is, like, first that when the dataset passed through the first decision tree, it got filtered, and then when it went to the second decision tree, it further got filtered. So this is a step-by-step process and involves complex computing, but it is efficient. It is more reliable, and the accuracy score of gradient boosting regressor is higher than the other regressors. So we will take a deep dive into the type of errors. We will now look uh, at the I've trained a model, and that model has a certain accuracy, and we will use these different types of regressors like gradient boosting, decision tree, and random forest regressors onto these models to check the accuracy score, and then we will compare which model has the better accuracy score. So let's go to our collab notebook. So first of all, I have used the decision tree algorithm, and as seen on the screen, this gives us an accuracy of that's a complex big number. We have used random forest regressor, and what that regressor does is that it also gives us a accuracy score. What is the accuracy score of random forest regressor? Let's see. uh, random forest regressor, it gives us it gives an other accuracy score. And then we have used gradient boosting regressor, and let's see what accuracy score does this algorithm give. And then we have actually compared all of the um, different regressors, and you can see that like linear regression, it gives the lower value. Gradient boosting is on the second, and random forest. So what has happened is, like, our data was a bit uncleaned, and the input that was fed to the model was not so good. That's why the accuracy score is that much higher in value. But uh, but you can say that the model, we can conclude and summarize it with this decision, that the model that gives the lesser value has the better accuracy.